We don't come back again. H Radio School don't come back.
Hello everyone, I am Mr. D, your favorite radio school teacher. On February 1st, H Radio School will be coming back to teach you literacy, numeracy, and STEM subjects.
This is for out-of-school children.
We will teach primary topics on Mondays at 11 a.m., secondary topics on Tuesdays at 11 a.m., and we will have a repeat episode on Wednesdays.
Hope all of una don hear o. Make una tune in on Mondays, Tuesdays, and Wednesdays around 11 a.m. Parents, if your pikin no dey go school, make una try make dem go school for radio so your pikin fit learn. This is an ACE charity initiative powered by Grand Force Foundation.
This is a secondary school session for out-of-school children. Hello listeners, my name is Adesomi Temitayo and I welcome you to today's English class on ACE Radio School. Get your books and pens and make sure to take notes. Before we continue, let us recap what we have learned so far. We have learned that conjunctions are words that connect other words, phrases, or clauses. We also learned that there are three types of conjunction, which are coordinating conjunctions, subordinating conjunctions, and correlative conjunctions. In our last lesson, we learned about subordinating conjunction, which connects an independent clause to a dependent clause. Example of such includes after, as long as, because, before, since, although, unless, and until. Today, we will study the third type of conjunction, which is correlative conjunctions. Can somebody say it? Correlative conjunctions. Correlative is spelled C-O-R-R-E-L-A-T-I-V-E. Correlative. Correlative conjunctions are pairs of words used to connect two parts of a sentence with equal value. They also connect two balanced clauses, phrases, or words together. Remember that correlative conjunctions comes in pairs. That means it always includes two conjunctions used in the sentence at a time. You also have to use both of the conjunctions in the sentence, or else the sentence will not make sense. The most common examples are either or, both and, neither nor, not only, but also, as so, whether or, no sooner than. Let's take a look at the following sentence examples. We'll start with either or. We can go to either Kaduna or Abuja for our holiday. In the sentence above, the correlative conjunction either and or connect the equal parts Kaduna and Abuja. Either and or have to be included in the sentence for it to make sense. 2. Both and. Both basketball and football are popular sports in Nigeria. In this sentence, the correlative conjunction both and connects the equal subjects basketball and football. You cannot say both basketball or football. It has to be both basketball and football. Therefore, both and have to go together for the sentence to make sense. 3. Not only, but also. Not only is he a professional footballer, but he is also a successful businessman. Joe not only likes pies, but also likes cake. Number 4, not, but. There are not 2, but 3 government libraries in my village. Sentence 5, neither nor. Neither Bashir nor Mahmoud is in the classroom at the moment. In a sentence, neither must go with nor. It cannot be used with other conjunctions like and, or, etc. Sentence number 6. Whether or. I don't know whether I am coming to your house or not. Sentence 7. No sooner than. No sooner had I finished watering the garden than it started raining. From these examples, you can observe that correlative conjunctions come in a pair and you have to use both of them in different places in a sentence to make them work. Alright, let's do a recap of what has been learned today. We learned that correlative conjunctions connect words of equal value. It also connects two balanced clauses, phrases, or words together. We learned the types of correlative conjunctions, which are either or, both and, neither nor, etc. Now it's question time. I'd like you to listen attentively to the following questions and choose the option with the correct answer. Are you ready? Let's do this. Question number 1. She is dash intelligent and beautiful. A. As. B. Both. C. Neither. I take question 1 again. She is dash intelligent and beautiful. A. As. B. Both. C. Neither. Question number 2. I will either go for a walk dash stay at home and watch TV. A. And. B. Nor. C. Or. Question 2 again. I will either go for a walk dash stay at home and watch TV. A. And. B. Nor. C. Or. Question number 3. Jerry is dash rich nor famous. A. Either. B. Nor. C. Neither. Question 3 again. Jerry is dash rich nor famous. A. Neither. B. Nor. C. Neither. A. Either. B. Nor. C. Neither. Send your responses as a text message indicating your name, gender, state, and subject, that is English, to 070-363-03182. I take the number again, 070-363-03182. Alright, well done students for participating with your friends in today's English lesson. You can catch up on past episodes on our YouTube channel called Ace Radio School. Don't forget to subscribe. Until I come your way again, it's Adesomi saying bye for now.
This is an ACE charity initiative powered by Grand Force Foundation.
This secondary school session is for out-of-school students. Hello listeners, my name is Mrs. Oluwashina Teniola and I welcome you to today's mathematics class on ACE Radio School. Today, I'll be teaching you factorization. I will explain how to factorize complex algebraic expressions. Get your pen and notebook and let's get ready to learn. Previously, I explained that factors are numbers that can divide through other numbers without a remainder. I'll take that again. Factors are numbers that can divide through other numbers without a remainder. For example, 6ab divided by 2 equals 3ab, and 6ab divided by 2a is 3b. Also, 6ab divided by ab equals 6, and 6ab divided by b equals 6a, and so on. Since 1, 2, 3, A, B, and 6 can divide through 6AB without a remainder. They are factors of 6AB. Let's consider this example. Factorize 6a plus bm plus 6b plus am. Factorize 6a plus bm plus 6b plus am. Firstly, let's regroup this expression by bringing the terms that are similar together. That will be 6a plus 6b plus bm plus am. Now let's put them in brackets. Open bracket 6a plus 6b close bracket plus open bracket bm plus am close bracket. Now let's find what 6a and 6b have in common. 6a and 6b have 6 in common. Great! This will become 6 open bracket a plus b close bracket. Now let's find what bm and am have in common. Am and bm have m in common. This will become m open bracket a plus b close bracket. Let's bring them together. 6 open bracket a plus b close bracket plus m open bracket a plus b close bracket. What do you notice? A plus b appears twice. Fantastic! But 6 and m are outside the brackets. Therefore, I'll bring them together as open bracket 6 plus m close bracket. Then I'll pick one out of the a plus b appearing twice. Hence, 6a plus bm plus 6b plus am equals open bracket 6 plus m close bracket. Open bracket a plus b close bracket. Great! Shall we consider another exciting example? Factorize 5r plus rs plus 5p plus ps. Factorize 5r plus rs plus 5p plus ps. Firstly, let's regroup this expression by bringing the terms that are similar together. That will be 5r plus 5p plus rs plus ps. Now let's put them in brackets. Open bracket 5r plus 5p close brackets plus open bracket rs plus ps close brackets. Now let's find what 5r and 5p have in common. 5r and 5p have 5 in common. Great! This will become 5 open bracket r plus p close the bracket. Now let's find what rs and ps have in common. Rs and p have x in common. This will become s open bracket r plus p close bracket. Now let's bring them together. 5 open bracket r plus p close bracket plus s open bracket r plus p close bracket. What do you notice? R plus p appears twice. Fantastic! But 5 and p are outside the bracket. Therefore, I'll bring them together as open bracket 5 plus p close bracket. Then I'll pick one out of the r plus p appearing twice. Hence, 5r plus 5p plus rs plus ps equals open bracket 5 plus p close bracket open bracket r plus p close bracket. Awesome performance! Let's consider another example. Factorize 2ax plus 2ay plus 3bx minus 3by. I'll take it again. Factorize 2ax minus 2ay plus 3bx minus 3by. Firstly, we do not need to regroup this expression because the similar terms are already together. Now let's put them in brackets. 2ax minus 2ay plus open bracket 3bx minus 3by close bracket. I'll take that again. Open bracket 2ax minus 2ay close bracket plus open bracket 3bx minus 3by. Now let's find what 2ax and 2ay have in common. 2ax and 2ay have 2a in common. Great! This will become 2a open bracket x minus y close the bracket. Now let's find what 3bx and 3by have in common. 3bx and 3by have 3b in common. This will become 3b open bracket x minus y. Let's bring them together. 2a open bracket x minus y close the bracket plus 3b open bracket x minus y close the bracket. What do you notice? X minus y appears twice. Fantastic. But 2a and 3b are outside the bracket. Therefore, I'll bring them together as open bracket 2a plus 3b close bracket. Then I'll pick one out of the x minus y appearing twice. Hence 2ax minus 2ay plus 3bx minus 3by equals open bracket 2a plus 3b close bracket open bracket x minus y close bracket. Quite easily done. Well done, listeners. We've come to the end of today's session. We learnt about how to factorize algebraic expressions. I'd like you to try this as an assignment and send in your answers to this phone number 07036303182. Type your name, age, gender. If you are a boy, type male. If you are a girl, type female. Your class and the state you currently live in. I hope you've done that. Now the questions. 1. Factorize ax plus ay plus 3bx plus 3by. I'll take it again. Factorize ax plus ay plus 3bx plus 3by. 2. Factorize pq plus qr plus ps plus rs. Again, pq plus qr plus ps plus rs. Okay, I'll be expecting your answers. You can catch up on past episodes on our YouTube channel called Ace Radio School. Don't forget to subscribe. Until next time, it's bye for now.
We don't come back again. Ace Radio School don't come back.
Hello everyone, I am Mr. D, your favorite radio school teacher. On February 1st, Ace Radio School will be coming back to teach you literacy, numeracy, and STEM subjects.
This is for out-of-school children.
We will teach primary topics on Mondays at 11 a.m., secondary topics on Tuesdays at 11 a.m., and we will have a repeat episode on Wednesdays.
Hope all of una don hear o. Make una tune in on Mondays, Tuesdays, and Wednesdays around 11 a.m. Parents, if your pikin no dey go school, make una try make dem go school for radio so your pikin fit learn. This is an ACE charity initiative powered by Grand Force Foundation.
This secondary session is for out-of-school children. Hello listeners, my name is Ibrahim Mak, your Ace Radio School physics teacher. Welcome to today's class on Ace Radio School. Kindly get your book and pen ready to take notes. Today, we will study the topic power in further details by solving some examples. Let us start with a quick summary of the things we have learned so far. We have learned that rate means time taken to perform a task, that force is mass multiplied by acceleration due to gravity, that work done is calculated as force multiplied by displacement, and that power is equal to work done divided by time. Today we shall utilize the previous knowledge gained during the study of power to solve a few problems. Let us start with this example. Two physics students, Ade and Ben, are in the weightlifting room. Ade lifts the 100 Newton weight to a height of 20 meters, 10 times in 1 minute. Ben lifts the 100 Newton weight to the same height, that is 20 meters, 10 times in 10 seconds. Which student does the most work? Which student has the most power? In this example, we know the mass of the weight that was lifted. We also know the displacement, which is 20 meters. Remember, to calculate the power, we need to calculate the work done first. The formula for work done is force multiplied by displacement. Let's get to the solution. Ben and Ade have done the same amount of work. Since they both lift a load of 100 Newton up 20 meters 10 times, the work done is force multiplied by displacement, which is equal to 100 Newton multiplied by 20 meters, which is equal to 2000 joules. However, since they both lifted the weight 10 times, it means the total work done by each of the students is 2000 joules multiplied by 10, which is 20,000 joules. Yet Ben is the most powerful since he does the same work in less time. Now that we know the work done, we can calculate the power. Power is calculated as work done divided by time. To calculate Ade's power, we divide the 20,000 joules by 10 minutes multiplied by 60 seconds, which is equal to 20,000 joules divided by 600 seconds. This results in 33.33 watts. Remember, in the last lesson we stated that the time taken should always be in seconds. Let's calculate Ben's power. Ben's power is 20,000 joules divided by 10 seconds, which is equal to 2000 watts. From the example above, we can also see that power and time are inversely proportional, meaning the more the power a person or thing has, the less time it requires to perform a task. Example number 2. The electricity we consume in our houses are usually measured in kilowatt hours. 1 kilowatt hour is the amount of electrical energy used when 1 kilowatt of electricity flows for 1 hour. What is the amount of energy in joules we get when we buy 1 kilowatt of electricity? I'll take the question once again. The electricity we consume in our houses are usually measured in 1 or more kilowatt hours. 1 kilowatt hour is the amount of electrical energy used when 1 kilowatt of electricity flows for 1 hour. What is the amount of energy in joules we get when we buy 1 kilowatt hour of electricity? Now the solution. Remember that in our first class, we learned that we can represent larger units of power in kilowatts and megawatts. We also learned that kilo stands for 1000, while mega stands for 1 million. Hence, 1 kilowatt is the same as 1 multiplied by 1000 watts. We get this by just replacing the kilo in front of the watt by 1000. But 1 kilowatt hour is 1 multiplied by 1000 watts multiplied by 1 hour. Always remember to work in SI units. Therefore, we will convert time from hour to seconds. To do this, we convert 1 hour to minutes by multiplying by 60 minutes, and then convert the answer in minutes to seconds by multiplying again by 60 seconds. Recall from your basic mathematics that 60 seconds make 1 minute and 60 minutes make 1 hour. Therefore, 1 kilowatt hour is 1 multiplied by 1000 watts multiplied by 60 minutes multiplied by 60 seconds, which results in 3.6 times 10 raised to power 6 watts second. 3.6 times 10 raised to power 6 watts second. However, the question requires we leave our answer in joules, not watts second. This means the question is asking us to calculate the work done. From the relationship, power is equal to work done divided by time taken. Work done can be calculated as work done is equal to power multiplied by time taken. If we make work done the subject of our formula, we get work done is equal to power multiplied by time taken. We can write down work done, the SI unit is joules, is equal to power, whose SI unit is watts, multiplied by time taken. Therefore, we can say joules is equal to watts multiplied by time taken. So, watts second is same as joules, or is equivalent to joules. And the answer to our question is 3.6 times 10 raised to power 6 joules. With this, we have come to the end of today's class. But before we go, I will give you some assignments. Kindly send your answers as a text message containing your name, your gender, if you are a boy, type male, a girl, type female, your class, the subject, that is physics, and the state you currently live in to 070-3630-3182. The questions are as follows. Usain Bolt set a new world record in the 100 meter sprint by generating 25 watts of power in 9.58 seconds. How much work did he do? The question once again. Usain Bolt set a new world record in the 100 meter sprint by generating 25 watts of power in 9.58 seconds. How much work did he do? Question number 2. What was the force used by Usain Bolt while running during the 100 meters race? What was the force used by Usain Bolt while running during the 100 meters race? Hint. Force is equal to work done divided by displacement. Send your answers to 070-3630-3182. I believe we had fun learning today. Till I come your way again on Ace Radio School, use your power to change the world.
This is an ACE charity initiative powered by Grand Force Foundation.